आज के इस वीडियो लेक्चर में हम डिस्कशन करेंगे लीनियर वेक्टर स्पेस इन क्वांटम मैकेनिक्स। ये आपका जो टॉपिक है वो मैथमेटिक्स से मिलता हुआ टॉपिक है। क्या डेफिनेशन हमारे क्वांटम मैकेनिक्स के आधार पर लीनियर वेक्टर स्पेस की है? A space consists of two set of elements। ऐसा कोई स्पेस जिसमें दो सेट ऑफ एलिमेंट्स हों and two algebraic rules of vector and scalars are followed are called vector space। Number one, set of vectors like psi state vector, phi state vector, chi state vectors, and so on, and set of scalars like a, b, c, dot 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 dot, and two rules, algebraic rules. One is the vector addition rule and other is the scalar multiplication rule. These rules are described below one by one. The first rule is addition. This rule has the properties: number one, if we take any two state vectors of the space, then their sum is also the state vector of that space. Suppose you have taken two vectors psi and phi that are the elements of the vector space, then their additive value will also the state vector of that space. Second property, if you have two vectors psi and phi of the vector space, then psi plus phi is also the vector of the vector space and phi plus psi is also the vector of the vector space. That means psi plus phi and phi plus psi both are equal. This is the commutative property of two vectors. One property is associative property. If we take three vectors of the vector space, then psi plus phi first take addition and then plus chi. So this can be written as psi plus phi plus chi. This is the associative property of vector space. And next property is existence of zero or neutral vector in the vector space. लाइन वेक्टर स्पेस में एक जीरो वेक्टर भी पाया जाता है कि जिस वेक्टर को अगर हम किसी के अपने वेक्टर के साथ ऐड करें तो स्टेट नहीं चेंज होती, मतलब सेम बना रहता है, जैसे जीरो प्लस साई इज इक्वल टू साई प्लस जीरो इज इक्वल टू जीरो। नेक्स्ट प्रॉपर्टी है एग्जिस्टेंस ऑफ इनवर्स इन द वेक्टर स्पेस। If psi is found in the vector space, then minus psi will also found in the vector space. So psi plus minus psi is equal to neutral vector. So existence of symmetric inverse vector in the vector space. Now take multiplication properties of scalar. If we multiply any scalar of the vector space with vector, then it will also be a vector and have some certain properties. First is the product of scalar with vector is another vector, just like A psi is equal to psi dash. It is another vector in the vector space. A is the scalar in vector space and psi is the vector in vector space, and their product is psi dash. It is also a state vector in vector space. If two state vectors psi and phi and two scalars a and b, their linear combination a psi plus b phi is also a vector of the space. Distributive with respect to addition, a is a scalar and psi plus phi is a vector. This can be written as a psi plus a phi. Another case is possible. A and B are the scalar, are taking addition first and taking product with wave vector psi, then you will get A psi plus B psi. Associative with respect to multiplication, A B psi is equal to A B psi. And last property, if we multiply null vector, zero vector with any state vector psi, zero scalar with any state vector psi, then you will get the null vector. Like 0 is a scalar and psi is a vector, you will get 0 vector. Similarly, if we multiply unitary scalar with wave function psi, then psi I or psi both are the same. These are the properties of scalar multiplication, and in first case are the properties of vector multiplication. So the space which have two set of elements, one is the vector elements, other is the scalar elements, and two properties, one is the addition, another is the scalar multiplication are follows, then that is called linear vector space. Dimension of vector space. Suppose our vector space have n vectors, phi 1, phi 2, dot 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 phi n. Is said to be linearly independent. All these vectors are called linearly independent if their equation a1 phi 1, a2 phi 2, dot 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 an phi n is equal to 0. It's possible with all scalars are 0. a1, a2, dot 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 an are 0. In this situation, the the vector space is called linearly independent, and phi I is called linearly dependent vectors if any one of scalar is not 0. जितने भी स्केलर हैं अगर सारे जीरो हैं तो लीनियरली इंडिपेंडेंट कहलाएगा। अगर इनमें से कोई एक भी नहीं जीरो है तो उसे हम कहेंगे, हमारे जो स्टेट वेक्टर्स हैं phi 1, phi 2, phi n, दैट आर कॉल्ड लीनियरली डिपेंडेंट। तो डायमेंशन का मतलब है कि कितने वेक्टर्स हमारे लीनियरली इंडिपेंडेंट हैं, that is called their dimension. The dimension of the vector space is given by maximum number of linearly independent vectors. मान लीजिए सारे आपके A1 A2 A3 AN सारे जीरो नहीं हैं तो वो लीनियरली डिपेंडेंट कहलाता है, लेकिन जितने मैक्सिमम नंबर ऑफ एलिमेंट्स जीरो होंगे उनको कहेंगे डायमेंशन ऑफ द वेक्टर स्पेस. सपोज phi 1 phi 2 phi n dot 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 all are linearly independent vectors, then it is called n dimensional vector space. मतलब this condition is satisfied, this, then it is called n dimensional vector space. Basis. The basis of the vector space consists of a set of maximum possible number of linearly independent vector belonging to that space. Consist of maximum number of possible number of linearly independent vectors belonging to that space is called their basis. This set of vectors phi 1 phi 2 phi n is denoted by this phi I is called basis of the vector, and each phi 1 phi 2 dot 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 phi n all are called base vectors. So phi I is called basis, written as in this form. This is a basis. All vectors are linearly independent, then their basis is this, and all elements of basis is called base vectors. In this way our topic of linear vector space, their dimension and basis is completed.